All right, so today we're looking at our second day of Unit 9 with volume. Yesterday we were working with volume of prisms and cylinders. And we know that our formula for those were volume is equal to the area of the base times the height. For pyramids as well as cones, our formula for those are going to be based off the same formula. So we see that the volume of a pyramid is 1/3 the area of the base times the height. With prisms, to find the area of the base, we had to look at the shape of the base. So like right here, in this one, we have a rectangular prism. So since this was a base that was the shape of a rectangle, we said length times width, that gave us the area of the base, and then we multiplied times the height of the prism. And we talked about how that the volume of prisms changed each time because the base changed. Well, let me rephrase that. The B changed each time. How we found B changed each time depending on the shape of the base. But for a cylinder, it was always the same base. They were circular bases, so the formula pi r squared was always used. But here we're told that the formula for the volume of a pyramid follows directly from the volume of a prism. The pyramid would always be 1/3 the volume of the prism with the same base and height. All right, so if we had this rectangular prism right here, and I had some magical cutting utensils, and I could come in here and cut out my pyramid. Actually get... All right, we can see that our pyramid has the same base, rectangular base, as the prism did, but the pyramid only has one base. Okay, so this volume of the pyramid is only going to be 1/3 of what the actual prism was. So for example, if I told you that the volume of the prism was equal to 120, and I asked you then what would the volume of the pyramid be? Well, we know that the volume of a pyramid is 1/3 the area of the base times the height. Well, the volume of the prism came from area of the base times the height. So all we have to do is just say 120 divided by 3, and 120 divided by 3 would give us 40. So the pyramid would be 40, have a volume of 40. On the other hand, if I told you that the volume of a pyramid was 30, and I asked you what would the volume of the prism be that the pyramid was cut out of, well, if we had to divide this by 3 to get that, then we'd do the opposite, multiply that by 3 to get this. So 30 times 3 would be 90. Okay, and you know how I always got cheesy ways of remembering things. So if we look at this right here, when this pyramid divides this prism into 3 sections, 1, 2, 3. And the pyramid is 1 out of 3 sections, so we get 1/3. It's kind of cheesy, but it works. Okay. Now, just like with most things, we've always got some vocabulary that goes along with it. So let's look at the parts of the pyramids and the matching vocabulary words. So we've got quite a few here, so let me go ahead and grab a marker that I want to use. All right, let's start with something that we all should know by now. All right, so the side that I just highlighted, we know that what this is actually called is called the base. The segments that make up the base, the sides of the base, are called the base edge. So these segments right here are called a base edge. Where the base edges meet And also with these segments, which we'll talk about what they're called in just a minute, where they meet, they intersect, these are called vertices. So that right there would be a vertex. Now, in looking at these 5 vertices, we see that one that stands out more than the others. And that one that stands out more than the others is this top one right here. That is called the apex. Okay. All right, so we got the base edge, the vertex, the apex. All right, now look at all the pyramids that I have on this worksheet so far. We can see that each side of a pyramid has a particular shape. And that particular shape is that of a triangle. So all the sides of pyramids are made up of triangles. Well, those triangles have a specific name. And that specific name is called a lateral face. Lateral means side. So these are the faces of the side. So it's a lateral face. Okay. All right, now coming in here. Last week, or should I say yesterday, we learned that when you have a segment that goes from the center of a polygon to the side, to the midpoint of the opposite side, that is called an apothem. So here, this segment right here is called the apothem. Okay. All right, again, the apothem goes from the center to the side, to the midpoint of the side, and since it goes to the midpoint of the side, it divides that side into 2 equal parts, 2 congruent parts. We've also got a couple of things that we've also taught about. Okay. All right. The segment that connects the apex to the center, that usually gives us our height. So this is our height, which we know most of the time we call it an altitude. All right, now we've got our base edge, we got our lateral face. Well, the sides that make up the lateral face also have a specific name. Okay, where the base edges are the edges along the base, the lateral edge are the edges along the lateral face. Okay. All right, we're just about got everything. Got a couple more left. All right, our next one is going to be the segment that connects the apex to the midpoint of the side of a lateral face. All right, notice this is an altitude because it's perpendicular, but it's not a vertical altitude because it's not going up and down. It's kind of on the lateral face, it's slanted. So that altitude of the lateral face, since it is slanted, this is going to be really hard to remember. Since it is slanted, it is called a slant height. And you'll see that represented by the letter lowercase l. All right. Then we also have our segment that connects the center to a vertex. We talked about this yesterday. This is called a radius. Okay, so those are all the parts of that pyramid. Who would ever know that it had so many parts? All right, so now that that's done, let's come here and actually start looking at our examples. And remember, anytime you can pause the video. Just like with prisms, pyramids are named by the shape of their bases. So right here we see that we have our base, and it is an 8 by 8. So since all the sides are the same, that makes it a square. So hence the name square pyramid. To find the volume of a pyramid, it's equal to 1/3 the area of the base times the height. So here, this is going to be 1/3. To find the area of a square, we say side times side, so 8 times 8 is 64. And then the height of the pyramid is 10. 64 times 10 is 640 divided by 3. We get 640 divided by 3 centimeters cubed. Now, this is the exact value for the answer. We didn't change it to a decimal. But if they did ask you to change it to a decimal, let's say rounding it to the nearest tenth or 1 decimal place, we would get 213.3 centimeters cubed. Sometimes they'll ask you to write it as an exact value. Sometimes they want you to write it as a decimal. All right. For example 2, all right, here's our base. We can see that this is a 4 by 6, so it's not a square, it is a rectangle, hence the name rectangular pyramid. Still going to do the same formula. The volume is equal to 1/3 the area of the base times the height. So here we're going to say 1/3 the area of the base. 4 times 6 is 24 times the height of 8. 24 divided by 3 is 8, so we end up with 8 times 8, which is 64. So we get 64 centimeters cubed. All right, for example 3. And looking at our base, we see that our base has the shape of a triangle. So this is called a triangular pyramid. All right, so finding the volume, 1/3 the area of the base times the height. So we got 1/3. All right, since it's a triangle, it's 1/2 base times height. So since it's a right triangle, I know that the legs of a right triangle are the base and the height. So 3 times 5 is 15. Half of 15 is 7.5. Then the height of the pyramid is 8. So we're going to say 1/3 times 7.5 times 8, and that's going to give us 20. So we get 20 centimeters cubed. All right, so in examples 1, 2, and 3, the height of the pyramid was given to us. But that's not always going to be the case. Sometimes we'll end up with diagrams where they give us the slant height, which is right here, and we have to use that slant height to find the height of our pyramid. Okay, so if you notice right here with the slant height, if I connect that to the height and the apothem, I get a right triangle. Okay. So we can use those 3 pieces together and find the height of our pyramid. So 6 is our base edge. We know that the apothem is always going to be half of the side. So if all the way across is 6, then half of 6 is 3. So here, this x is going to be replaced with a 3. So I'm going to redraw this triangle so we can actually see it away from the pyramid's diagram. All right, my slant height is 5, my base is 3, and I'm looking for my height. I know 2 sides of a right triangle, so I can use Pythagorean theorem. So I've got leg squared plus leg squared is equal to the hypotenuse squared. So it's going to give me h squared is equal to 25 minus 9, which is 16. So here I'm going to get h equals 4. So my height is 4. Now I've got everything I need to find the volume. So I'm going to say the volume is equal to 1/3 the area of the base. So 6 times 6 is 36 times my height of 4. 1/3 of 36 is 12, and 12 times 4 is 48. So I get 48 centimeters cubed. Again, remember you can pause the video at any time. All right, for our next example, this is definitely a multi-step problem. Okay, so first thing I notice is that I'm not given the height of my pyramid. That's something I need. And then last problem, we were given the apothem and the slant height. I can easily find the apothem. Right here, if the whole side is 10, then half of 10 would be 5. So if you notice, I've only got one value of my triangle here, this right triangle. I don't know the slant height. So what we're going to have to do is we're going to have to use what they give us to figure out everything. So it's like a multi-step problem, basically. What I do see is that they gave me the lateral edge. So I've got my lateral edge right here. So the lateral edge. I'm going to use that to find my slant height. Because I know the base, I know the lateral edge, I just need this piece right here. So let's redraw that one so that we can just focus on the triangle at hand instead of trying to look at it through the whole figure. All right, and look at this right triangle right here that I have highlighted. The lateral edge acts as your hypotenuse. So the hypotenuse here is 13. All right, I know that the base is 5, and I'm looking for L, my slant height. Once again, I know two sides of a right triangle. So I'm going to come in here and say leg squared plus leg squared is equal to hypotenuse squared. Okay, so I get leg squared. That is 25, that is 169, so 169 minus 25 gives us 144. The square root of 144 is 12. So my slant height here is 12. All right, so now what I notice is that I know my slant height, I know my apothem, and that's enough to find my height like we did in the previous example. So again, I'm going to redraw that triangle so I can just focus on those numbers because looking at all this, it can be easily confusing. All right, so my slant height for this one is acting as my hypotenuse, so that's 12. I don't know my height, but I do know that my apothem is 5. Oops, why did I put h squared there? Meant to put an H. So using the Pythagorean theorem again, I'm going to say leg squared plus leg squared is equal to hypotenuse squared. That's going to give me 25. That's going to give me 144. 144 minus 25 is 119. So when we take the square root of 119, I simply end up with the square root of 119. So the height here is the square root of 119. So we got our height finally. So coming in here, finding our volume. So it's going to be 1/3 the area of the base. All right, so 10 times 10 is 100 times the height of your pyramid, which is the square root of 119. Can't multiply these two together because this is a whole number and this is a radicand. So we have to leave it as 100 onto the square root of 119, all divided by 3 centimeters cubed. Now again, this is the exact value. They may ask you to round it. So if we rounded that, we would end up with 363.6 centimeters cubed. So make sure you read the directions to see what they want you to do. All right, for cones, okay, cones, they all have the same circular base, so it's not going to change that much. So again, the volume of a cone is 1/3 the area of the base times the height. But since the base is always going to be a circle, we can replace that b with pi r squared, because that's how you find the area of a circle. So again, just like with a prism and a pyramid, a cone is cut from a cylinder. And it is 1/3 the area, 1/3 the volume of the cylinder. So, finding the volume for these three cones here. Okay, so we got the volume is equal to 1/3 pi r squared times h. So we get 1/3. Our radius here is 3, so 3 squared pi, and then our height is 8. The height connects the apex to the center. Or sometimes they call it an apex, sometimes some worksheets might just call it the vertex, because it's the only vertex there. Okay, so our height is 8. 3 squared is 9, 39 is 3, so 3 times 8 is 24. So 24 pi centimeters cubed. And remember, since I didn't use pi to multiply, this is what we call the exact value. Now on your homework worksheet, you'll see it will say volume equals blank, and it might have a little e right there. That means it wants you to have the exact value. Sometimes you might see parentheses with 2 DEC. That means they want you to round it to 2 decimals. All right, for example 2. The volume is equal to 1/3 pi r squared times h. Here they give us the diameter, and I know the radius, which is what I need, is always going to be half of the diameter. So if all the way across is 12, then our radius is going to be 6. So we get 1/3 6 squared pi times h, which is 4. 6 squared is 36. 36 divided by 3 is 12, and 12 times 4 is 48. So we get 48 pi centimeters cubed. Volume is always in cubic units, area is always in squared units, and perimeter is always in just a regular unit. Now, wrapping it up on this side with example 3. Again, we've got our cone, but I see that I'm missing the height. So I can come in here. I see I got the radius of 5, the slant height of 13, so that's just another right triangle that I know 2 sides for. So I got 13 and 5. So I need the height. So the height squared is going to be equal to my hypotenuse squared minus my leg squared, because that's essentially what we end up doing. So that's going to give me 169 minus 25, which is 144. So when we take the square root, what times itself gives you 144? That would be 12. So the missing height is 12. So the volume is equal to 1/3 my radius, which is 5 squared, times the height of 12. 5 squared is 25. 12 divided by 3 is 4, so 4 times 25 is 100. So we get 100 pi centimeters cubed. All right, going to our odds and ends section. In yesterday's lesson, we talked about regular polygons. And we said that regular polygons are polygons that have the same lengths for their sides, as well as equal angular. It's both equilateral and equal angular. The sides are the same length, and the angles are also congruent. Okay, so here we see that we've got a hexagonal pyramid. Now, someone asked me the question yesterday, is that whenever you have a hexagon or a pentagon, is it always going to be regular in these diagrams? And I said yes. If it's not, what they do is that they give you the area of the base so that you don't have to calculate it. Okay? So We know that when we have a regular base, that we have to use the apothem to find the formula for the area. So here we've got the volume is equal to 1/3 the area of the base times the height. Since this is a regular hexagon, that means the area formula would be 1/2 AP and then times the height of the pyramid. And remember the A stands for the apothem and the P is for the perimeter. So I showed you yesterday how to mathematically find this, but then I also told you about a shortcut. So to find the apothem, okay, and I'm just going to come right here and just draw this. To find the apothem A, all you're going to do, basically for the shortcut, is you're going to take half of the base edge and attach the square root of 3. Mathematically, we've used our 30, 60, 90 rules and figured it out. So when I come right here, we'll say 1/3 times 1/2, my apothem, all right? If all the way across is 11, half of 11 is 5.5. And then I'm going to attach the square root of 3. And that's not 5 times 5, that's 5.5. Okay, then I need the height, or the height of the pyramid is 13. Oops, I forgot my perimeter, didn't I? Let's come in here and find the perimeter. Okay, if there are 6 sides, and all 6 sides are 11, 6 times 11 is 66. So here's our 1/3, our 1/2, our apothem, our height, and then I forgot to throw in my perimeter, but when multiplying, the order does not matter. We'll put this into the calculator, and let's round to the nearest tenths. So when you put all this into the calculator and round to the nearest tenths, you're going to get 1,362.3, and let's say this is feet. So feet cubed. All right, for our composite figure, we see here we've got a pyramid and a prism. And they've been pushed together, and that's what composes our composite figure. So when we push them together, we are creating a mathematical situation where we have to find the volume of this shape, find the volume of this shape, and then add them. Okay, so let's start with the prism. For the volume of the prism, I'm just going to go old school and do length times width times height. So we got 24 times 8 times 5. All right, so let's see. 24 times 8 times 5 gives us 960. For the volume of the pyramid, I'm going to do 1/3 the area of the base times the height. So here we'll say 1/3. All right, my base is a rectangle. That's a 24 by 8. So 8 times 24 gives us 192. But if you notice, I don't have the height of my pyramid. So I've got to figure that out. And what we're going to do is we're going to come in here, and we're going to draw in our altitude and our apothem. So right here's my center. If all the way across is 24, we know the apothem is half of that base edge. So half of 24 is 12. And I need the height. So what I have again is a right triangle that I know 2 sides for. So I'm going to do my hypotenuse, 25 squared, is equal to my height squared plus my apothem squared. And this is what, 625 and 144? So let's see, 625 minus 144 gives us 481. So we get h squared equals 481. Taking the square root. All right, so this is not a perfect square. Thought for sure I arranged it so it would be a perfect square, but I guess I didn't. Let me double check to make sure. All right, computer, what are you doing? Sorry, hold on, it's just a delay. My computer just went black. All right, there we go. Let me double check to make sure I got the numbers that I wanted. If not, we'll just keep rolling with it. It's no big deal. Yep. I wrote a number in wrong. Let's try this again. All right, so. And that's still going to be fine up there. This is what will change. Bear with me for a second, ladies and gents. All right, let's try this again. This was supposed to be 48. All right, so if the whole side is 48, then half of that would be 24. There. All right, so let's try this again. This will still be 25. All right, so 25 squared minus 24 squared gives us 49. And then taking the square root, we get h equals 7. All right, now, for those of you who are here in person, you know that we had a different example, and that's perfectly fine. All right, so let's see. We've got 192 times 7, and we'll divide that by 3. And we get our volume is 448. And let's do inches here. So inches cubed. All right, for number 3, we've got a cone, but if you notice this time, they're giving us a 30-degree angle. So this is where we've got to come in here and use our special right triangle rules. So I want to go ahead and draw him a radius. Okay, the volume of a cone, remember, is 1/3 pi r squared times the height. We don't know the height, and we currently don't know the radius, but we've got enough information to find it. Okay, so the altitude and the radius are going to create that 90-degree angle, so we got that right triangle. In a 30-60-90 rule, opposite of 30 is x, and the hypotenuse is always 2x. So if 2 times x gives you 20, that means x is 10. So opposite of 30 is going to be 10. And this is a 30, this is 90, so this is 60. Opposite of 60 is always x onto the square root of 3. So then that's going to be 10 onto the square root of 3 because we found x to be 10. So now we've got everything we need. And let's do 2 decimals. Let's do like some of the homework problems. Let's do 2 decimals. All right, so we'll say 1/3 the radius of 10 squared times pi times our height of 10 onto the square root of 3. So 1/3 times 100 times pi times 10 onto the square root of 3. And rounding it to 2 decimals, we get 1813.80. All right, let's say, what's something we haven't used in a while? Let's do kilometers cubed. All right, looking at number 4. All right, here we've got an oblique cone. What an oblique cone is, it's like a slanted cone. Basically, it's when your vertex is not above the center. Same applies to pyramids. We can have oblique pyramids, we can have oblique cones. That just mean they're slanted. The vertex is not over the center. Okay. Well, if you notice, we've got a right triangle right here. So we're going to say 1/3 pi r squared times the height. Our height is going to be given by this right here, and then for the radius, we need to find the diameter. But this is going to be really easy, and I'm not just saying it because I'm a math teacher, I really do mean it. If this is x, because this has the tick marks and this too, this means that this is also x. So what we've got here is x squared plus x squared is equal to the hypotenuse squared, so 8 onto square root 2 squared. Well, 1x squared plus 1x squared gives us 2x squared, and then 8 squared times 2 is going to give us, what, 128? Let's just double check. So I'm going to do 8 onto the square root of 2, square that, and we do get 128. All right, 128 divided by 2 will give us 64, and then taking the square root, we get x equals 8. Okay. All right, so this is what we really have as a 45, 45, 90 triangle. Since it's isosceles, that means that these two angles are equal. So if this is 90 of the 180 that a triangle is supposed to equal, these two together equal 180, equal 90, and then you divide it by 2. In a 45, 45, 90 triangle, it's always going to be x, x, and then x onto the square root of 2. So whatever's in front of the square root of 2 is your side. Now the 8 represents the diameter, so we need half of that, 4. So we're going to have 1/3, the radius, which is 4, squared pi, times the height of 8. Okay, let's leave this as an exact answer. Okay, so 4 squared is 16, and 16 times 8 is going to give us 128 over 3 pi. We can't do any reducing, so we're just going to leave it like this. All right, almost done. 2 more examples. All right, so looking at this, number 5, we got another composite figure. I see a cylinder and I see a cone. Okay, so since this is a composite, we know we need to add them together. So let's go ahead and do the volume of the cylinder. Okay, so that's going to be area of the base. So we got the radius is 8, so 8 squared pi times the height of 12. So let's see, 64 times 12 gives us 768. Now, if you notice, for the cone, we don't know the height, but I think we've got enough information to find the height. If the radius of the cylinder is 8, that means the radius of the cone is also 8. So when I draw in the altitude to create the height, I've got a right triangle that I know 2 sides for. So I'm going to say my leg squared is equal to the hypotenuse squared minus the other leg squared. So we got 100 minus 64, which is 36, and square root of 36 is 6. Okay. So now we got everything we need for the volume of the cone. So we got 1/3 area of the base, so 8 squared pi times the height of 6. Let's see what this is going to give us. All right, so 8 squared is 64 times 6, and then divide that by 3. We get 128 pi. We're going to add these two volumes together. So 128 plus 768. That gives us 896 pi. All right, so this is usually where I stop for standard. Then for honors, I introduce one last example. And that is the volume of a frustum. What is a frustum? It is this shape right here. Okay. What a frustum is basically is when we had a cone and we cut out the top section of the cone. So what we have to do is we have to find the volume of the larger cone, then find the volume of the cone that we cut out, and subtract the two. So let's figure out how to do this. All right. Okay, we're given that this right here is 12, but we don't know this length right here, so let's just call this x. We don't know the height of the cone, so that's h. Okay, so what we're going to do is we're going to come in here and we're going to look at it a little bit different. This is kind of three-dimensional. I want to look at it as just two-dimensional. Okay, so if I come right here and say, well, redrawn this, very two-dimensional, and obviously I'm not drawing it to scale. What I have right here is that the diameter is 12.5. So half of 12.5 would be 6.25 for the radius. Okay. If the diameter here is 10, then each radius would be 5. Now obviously this is 12, this is x, so then the whole side would be x plus 12. X plus 12. All right, that's going to give us enough information to figure this out. You're thinking, well, what? We're going to go back to our similar triangles that we learned back in Math 2. We're going to use something called the LSF, the linear scale factor. In similar triangles, there's a theorem that says that the sides are proportional to each other. So if I do the radius of the little cone to the radius of the big cone, that's going to be the same ratio as the side of the little cone to the side of the big cone. So it's it's that scale factor. So let's figure this out. Now, I'm going to do the big cone to the small cone. Okay, so the radius of the big cone is 6.25. The radius of the smaller cone would be 5. 6.25 divided by 5 is 1.25. So that is our linear scale factor. So that means if I come in here and say a little left side, well, I gotta do big side to small side. Okay, so big left side, x plus 12, to the little left side of x, that's going to be equal to 1.25. Well, this is actually a proportion. If I put this over 1, I can cross multiply and solve it. So let's do that part. All right. X times 1.25 gives us 1.25x. 1 times x plus 12 is x plus 12. This is a 1x. If I subtract that 1x from both sides, I get 0.25x equals 12. And then dividing by 0.25, I get x equals 48. So this right here is 48. So if that's 48, then I know the whole side is 60. Okay. Well, now that I've got that figured out, I can use Pythagorean theorem to find my missing pieces. All right, if this is 48, this is 60. So if I come right here and look at this triangle right here. All right, so I've got my hypotenuse squared. Well, let me just redraw that piece. Okay, so that is the hypotenuse, 48. My radius is 5, and I'm looking for the height. So I've got my hypotenuse squared is equal to my leg squared plus my leg squared. All right, so let's see. 48 squared minus 5 squared gives us 2279, and I'm going to take the square root of that. And let's see, they want 2 decimals, so we're going to round the 2 decimals. So that's going to give me 47.74. Okay, so that's the height of the little one, 47.74. Now I need the height of my larger triangle. Okay, so let me bring this out a little bit so we can see the whole problem. All right, my hypotenuse is going to be 60. My radius is 6.25, and I'm looking for the height. So I'm going to do hypotenuse squared is equal to the height squared plus 6.25 squared. So again, 60 squared minus 6.25 squared, because the opposite of adding 6.25 squared is subtracting it. And then I'm going to take the square root. And that gives me 59.67. So here H is 59.67. So, all right. So 59.67. So now I'm going to find the volume of the larger cone and subtract the volume of the smaller cone, and that will leave me with the volume of the frustum. All right, so let's do volume of the big. All right, volume of the big cone is equal to 1/3 the area of the base. All right, so our radius here, remember, was 6.25 squared times pi, and then the height is 59.67. So let's see, 1/3 times 6.25 squared times pi times 59.67 gives us 2440.87. Now let's do the volume of the smaller cone. So we got 1/3. The radius of the smaller cone was 5, so 5 squared pi. The height of the smaller cone was what? 47.74. One-third times 5 squared times pi times 47.74. We get 1249.83. Finally, we're going to subtract these two values right here, the volume of the big one minus the volume of the small one. So 2440.87 minus 1249.83. That gives us 1191.04. So the volume of the frustum is 1191.04.